Alright, so in this video, we're going to talk about the 2016 DSC Paper 1 question 13, which is about the congruent triangle. So before we talk about this question, we can have a quick revision about what's the meaning of the congruent triangle. So actually, we have 5 different cases. So we have SSS, SAS, ASA, AAS, and RHS. So the S means that is the side, the A means that is the angle. So if you have a congruent triangle, which means that all of the sides are the same and all of the angles are the same as well. So to prove a congruent triangle, we need to fulfill some of the criteria. For example, in this SSS, this 3 pair of the sides must be the same. Then if the 3 sides are the same, then we have the SSS. Then for SAS, we can see from here, starting from the S, and then we're passing through the angle, is another side. So we have side, angle, side. And then for the third one, we first passing through the angle, and then it's a side, the last one is the angle. So we're using an angle, side, angle. And then for the next one, we're passing through the angle, and then it's going meet the angle again, and then there's another side. So we're using the AAS. And for the RHS is a special case. The R is representing the right angle here. So first we need to have a right angle. And then H is representing the hypotenuse, which is the opposite side to the right angle. And then we just need to have either which pair of the side, doesn't matter. So that's 5 different proving reasons for the congruent triangle. So first of all, let's have a look. So we have the BE is equal to CE, so I highlighted in blue. And then we have the angle ADC is equal to the angle AEB. The next one, we have the DM is equal to ME. And then we now need to proving that the triangle ACD is here. This triangle is going to congruent to this triangle. Because it's an overlapped triangle, so we're trying to separate it into 2 different triangles. So remember to write it in the order. So because we have ACD is in this direction, so ABE we need to in this direction as well. So first of all, we can highlight something in the thing that we highlight in red. We have ADC is equal to AEB, which is given. So ADC is equal to AEB. So this 2 angle is given to be the truth. And then after that, because in an isosceles triangle, if we have the base angle are the same, then this 2 sides is going to be the same as well. And we can say that AD is equal to AE. The reason here is using the sides opposite equal angles. So we can label that. It's highlighted in orange. So AD is equal to AE is here. Then the last one can using the BD is equal to EC, which is given and highlighted in blue. So BD is equal to EC. But this criteria is not in our triangle the triangle that we want, isn't it? But if we're using the BD plus this side DE, it's actually the same as using the side EC plus the same length DE. So originally we have BD equal to EC. If for BD you plus the DE together with the EC you plus the DE at the same time, then you can get a BE is actually equal to DC, where BE is actually here and the DC is here. So this 2 length is actually the same. Then now we can conclude that this 2 triangles is actually congruent because we can see from here there's a pair of the side passing through the angle and another side. So we can say this is a side angle side type congruent triangle. So that's for part A. And now we have a look at part B. So suppose that we have the AD is equal to 15, AD equal to 15, BD is equal to 7, and then we have the DE is equal to 18. So the whole thing here is going to be 18, which means that this 2 small part is going to be 9 because they told you that DM is equal to ME. So now we have the DM is equal to ME, and this is actually an isosceles triangle. So we can using a property of the isosceles triangle to show that the AM is actually perpendicular to DE, which means that the angle AME, and the angle AMD is actually equal to 90 degrees. So this is actually a right angle triangle. So if we consider the ADM is a right angle triangle, so I draw it out here, ADM, then now I can say that the DM squared plus the AM squared gonna giving you the hypotenuse side AD squared. Then we can just substitute numbers that we have. The DM is actually equal to 9, so 9 squared plus AM squared equal to 15 squared. Using a calculator, you can find out that AM should be equal to 12. Then for B2, now we need to show that it is ABE, it is a right angle triangle. So ABE is here. So to show that it's either a right angle triangle, which means that we need to find all of the sides here. So first of all, if we consider the triangle ABM is here. I consider about this right angle triangle. So we can say the BM squared plus the AM squared should be equal to this AB squared. by using the Pythagoras theorem, you can find out the AB, the whole length AB is going to be 20. So I write down here, this is going to be 20. And then now we can consider the required triangle ABE. Let's consider this triangle. So if we consider the AB and AE squared plus them together, so 20 squared plus 15 squared is actually giving you 625. I mean 625. And then if we consider BE squared is equal to 265 as well. So which means that we have the AB squared plus AE squared is actually equal to BE squared. So by using the converse of the Pythagoras theorem, when two sides squared adding up is equal to the hypotenuse side, then the angle in the middle here is going to be 90 degrees. So now we show that the angle BAE is going to be 90 degrees, which means that the required triangle ABE is actually a right angle triangle. All right.